Let's do it. Good afternoon and welcome to the session panel 5 on power infrastructure and balancing industry and researchers. The goal of this panel is to discuss the vulnerability of the power infrastructure to wildfire impacts and threats to reliability. And I was reflecting a little bit on the previous panel and especially my colleague from Coors. Nobody's going to call him up at 3 a.m. and say, guess what? That shutoff worked beautifully. Because you don't know if you would have had a fire or not, right? If he had left it in. And this is the bane of our industry many times, is we take actions to make things reliable, secure, resilient, and you don't get a call saying, hey, that was a great job. You only get a call at 3 a.m. when it didn't work. So that's kind of the business we're in. We're trying to make sure that we don't have damage from wildfires, but also think about the system overall and its sensitivity to weather overall. And some of the work that you're doing here with wildfires certainly has knock-on information and effects for too much wind turbines then feathering, smoke, we'll hear a little bit more about that, or fog, or clouds, and the impact on solar. And of course, then we're becoming much more of an energy-constrained system, one which, we used to be able to plan with capacity based on nameplate, the total megawatts that a plant would generate. Now it's going to vary with a great deal of uncertainty. So even though we get the engineering right, making sure we install these facilities correctly, make sure they ride through and support reliability, even if we get all that right, we still have to deal with the uncertainty that we call weather. And it's not really random, and we have these weather conditions that take out thousands of megawatts of resources at one time, which is a little bit different than perhaps when you have a tornado come in or a hurricane, and of course we have mutual assistance and crews run out and help each other. In many cases, when these events occur, they occur in a time in which your neighbor can't help you, as you heard my colleague mention before, but rather you hopefully have been able to plan with a sufficient amount of transmission going long distance. And everybody loves transmission, right? One of the solutions on justice is to build more transmission. Nobody wants to build transmission though, right? Nobody likes that. We think it's beautiful, right? Right-of-ways. Look at my colleague, Steve Ashbaker, underneath the little right-of-way there. We think, us engineers, we think that's great, but most people don't like lines. So, and of course, that's one of the challenges that we're facing. So with that, of course, we're looking for outcomes here to understand the power infrastructure vulnerabilities and how satellite data can be used to improve planning activities and future infrastructure decisions, which is an exciting potential opportunity. My colleague here, Branden Sudduth from WECC, and I are going to be co-chairing this. And with that, I think we'd like to introduce Steve Ashbaker, who's also from WECC, Western Electricity Coordinating Council. We're brothers. The organizations, not Steve and I, in reliability development, standard development, auditing those standards, making sure the folks are following it, and also doing a lot of planning and studies as well as kind of performance evaluation. So, hey, Steve, can you kind of walk us through your deck?
Yeah, sure. Can everybody hear me okay?
Yes.
All right. Well, as noted on the screen there, I'm the Reliability Initiative Director at WECC, and I work for Branden. What I wanted to do to try to kick this panel off with is just kind of talk about an initiative that we've started up here the last couple years, and that's a wildfire data request that we've been doing. And this is a tool that we are trying to find a way to basically monitor and assess the vulnerability of the power infrastructure system to wildfire impacts, and what are some of the trends that we're seeing in this data that we're collecting. And so if you would go to the next slide, I'll give you just a little bit of an example of some of the data points that we are asking for. You can see here, we're looking for the total reported incidents by years. And actually, one thing that I should note here is that the relevant reporting period that we did for the 2022 data request was a 5-year period, roughly January 1, 2017 through July 11th, 2022. We had some 44 transmission operators that participated in this data request. Not all of them had information to supply, but we looked at the total incidents by voltage class. We looked at the duration in hours the lines was removed from service by voltage and year. We wanted to see kind of the percentage of voltage lines affected by it, which class of voltages, and I'll talk briefly a little bit about that. We do have what we call our WECC major transmission list, and it's a major set of key paths that we monitor. We ask if there was any impact to those paths. We ask about the number of incidents on BES facilities. We ask for the average duration in hours that the incident by voltage class, the number of transmission line outages by reason for the line was removed. We looked at the average amount of load drop. We wanted to see what sort of customer impact there was, the number of customers that were being lost. And then we began the second year starting to look into a little more on information on the PSPS programs, or those preemptive programs where you're actually de-energizing facilities. And there's been a lot of conversation in the last few panels, and I think you'll probably hear more in panel 6 tomorrow morning on that. But if you'd go to the next slide. So kind of what I want to do is just give you a little bit about what we're trying to find out with all this data. You know, we're trying to determine, are there transmission lines that are more susceptible to wildfire trips? Are there transmission lines that are actually initiating wildfires increasing over time? What trend can we see for the lines taken out of service due to PSPS programs or similar programs? Are there any changes that we need to do to the reliability standards, particularly the vegetation management FAC 003, and then WECC has its own maintenance standard FAC 051, which is applicable only to those set of key transmission lines that I spoke to. We're also looking to see what kind of trend are we seeing related to wildfires in terms of size, the number and duration in the West. And one thing that I'll show you, I put together, and Brad, don't get too concerned. I'll try to get through these 10 slides and won't tie up any more time than I have to. But I've got a set of slides that are showing some wildfire perimeters. And the main reason we developed those slides and those perimeter mappings was we kind of wanted to see how are fires propagating across the Western interconnection. For a number of years early on, we talked about just California. But we soon learned that fires were starting to propagate into the Northwest, eventually into the Southwest, across Idaho, into the Rocky Mountain area. So we wanted to kind of see just how are fires propagating across the Western interconnection. One of the things that we did note in part of this analysis is that there is really no strong correlation between wildfire number or severity and risk to the BPS. This is largely because fire location is the dominant driver of risk to the BPS elements. Location. So let's go to the next slide. One of the things that we feel is a benefit to this is gathering data over time. Again, this is only our second year. This will be our third year in doing this, 2023. The more data we can gather, the more data points we can gather, the better statistical analysis we can do as to what sort of risks are we seeing, what sort of trends are we seeing. Gathering data from all of the TOPs rather than a subset of those gives us a broader awareness of how the wildfires are impacting entities across the entire interconnection. Our original first year, we only looked at 9 specific TOPs, basically in California and a couple in the Northwest. The data also provides us an annual view of the interconnection performance during wildfires. So if we could, let's move to maybe the first wildfire mapping slide that I have. So this is 2017, and that rusty red color, as you can see there, is the wildfires in the US reported within the Western interconnection, the actual perimeters. And you can see there was approximately 1 million acres burned in 2017 in the Western interconnection. There were 37 mapped perimeter fires. 18 entities, as you can see there, reported 220 total incidents. Let me clarify here. What we asked for was what facilities 100 kV and above were impacted by wildfires. And so during 2017, we had 220 events where facilities were impacted. You can see we had 15 unknown fires. We're seeing quite a bit of that, and these basically could be roadside fires that don't really have a name. We use the NIFC fire site for identifying and naming the fires. And then we just got some comparison data down there to the total number of fires in the US and the actual acreage burned in the US to kind of compare how's that comparing to the number of acres and fires burned in the Western Interconnection. Let's go to 2018 and I'll show you again. You'll see a little different picture here. You can see that we're talking about 1.6 million acres, 32 map fires, 18 entities reporting 142 total incidents. So again, you can kind of see that total acreage does not always mean a lot of incidents. Again, there were 15 unknown fires that were unmapped here. And then the comparison again that you can see with the US totals there as well. So let's go up to 2019 and see if there's a little bit of a difference. This is considerably quieter in terms of fire. Roughly 270,000 acres were burned. 15 mapped perimeter fires. 13 entities reported 209 incidents or actual facilities being impacted. So here again, you can see only 270,000 acres, but 209 actual events were reported. Again, that comparison that acreage doesn't always mean there's going to be a lot of fires or a lot of outages. So let's look at 2020. This was a relatively large year in terms of fires. You can see that we have a considerable amount of activity in California, most of California, starting to move up into the Northwest, up into Washington, Oregon, parts of Idaho. You're seeing more activity in the Rocky Mountain area and also down in the Southwest, down in Arizona and Mexico. One of the things that I didn't explain up front was this gray shaded area is the perimeter of the participating TOPs. So those gray little figures that you're seeing, that gray shaded area, is actually the footprint of the 44 TOPs that participated. So it gives you kind of an idea where those fires were located by state and by TOP footprint. Let's go to 2021, which was our last year. And again, here you can see 2.5 million acres burned, 45 mapped perimeters, 137 total events. So with that said, we're looking at, when you look at some of the data, we've obviously got a huge data set of plots and trends that are really great to show you kind of the by voltage class, how many lines should we see. One of the things that I can tell you is that 62% of the events during this relative reporting period of time were in the 100 to 199 kV and the 200 to 299 class, voltage class. We had roughly 969 total events. And like I say, 62% of those were in that 100 to 199 to 299 kV class, voltage class. And one of the things to recognize is that in WECC, we have roughly 102,000 and some change total mileage of transmission lines. And out of that, we have about 35,000 plus lines in both the 100 to 199 and the 200 to 299 class. So you can see why there's probably a higher percentage of those voltage class lines being impacted by fire, plus the geographical location of those lines in proximity of the type of terrain, the type of fuel. So that's probably a leading reason why you see a higher number of fires in that voltage class. Last year when we requested information on the PSPS program, we had 8 entities that reported they had programs. I think someone mentioned in an earlier panel today that there are a number, I think it was probably Tim, there are a number of other entities within the Western Interconnection that are putting in place within their, as part of their wildfire mitigation programs, these preemptive programs. They're not always called PSPS, but they're some form of preemptive de-energization of transmission facilities to reduce the risk of ignition of fire. During the relative reporting period of this event that we just did in 2022, primarily from 2019 to 2021, which is when it was around 2018, I think, when most of the entities in California began utilizing the PSPS programs. But during this relative reporting period, we saw 256 PSPS events across a 3-year period, 2019, 2020, and 2021. So we continue to keep looking to see more information this year. Obviously, we'll have more entities having these types of programs in place. We'll see how that number changes. One of the interesting facts over this 5-year period is the fact that we've only identified, based on the information reported, that there were 10 incidents reported that actually facilities contributed to causing a fire. 6 of those events were reported in 2021 wildfire data request. There is one of those events that basically right now is being disputed. But if you look at the 5-year window, we're not seeing a huge increase in the number of events that have been reported that are contributing to the ignition of a wildfire. Obviously, in my conversations with utilities in various forums, there is some reservation to report this information until it's definitive that they actually caused that. So there may be some delay in actually reporting some of these incidents. But this is just a little bit of the information that we're attempting to collect. We're going to be initiating our wildfire data request again this year, but we are going to a slightly different timeline. We're going to be looking at a 12-month period. We're going to be looking at January 1, 2022, January 1, 2022 to December 31st, 2023. That data request will go out in January of 2024 with a due date of February 8th. We'll begin our analysis, hopefully being able to present that analysis and any of those trends to our executive team and to NERC and FERC, and then eventually to our stakeholders. And so with that, I'll give the remaining time, and if there's questions as we get through with the rest of the panelists, I don't want to take away from them. I'll certainly be open for any questions you might have on this process.
So next is Tim Beach. He works with the RC West, the reliability coordinator, by the way, TOP's transmission operator, BPS as a bulk power system. So we have our acronyms and we kind of understand it, but which is also with Cal ISO. And of course, yeah, they have a unique set of experiences there with dealing with the wildfires and you heard his questions earlier around some of the shut-off programs. So, hey, Tim.
Thanks, Mark. So I'm Tim Beach, Director of Reliability Coordination at CAISO or RC West. RC West is a division within CAISO. Many of the other independent system operators have a similar setup across the country, and I'll show you a slide later of who those people are. This is our facility in Folsom, California. We operate 2 control rooms, one here in Folsom and another in Lincoln, California, which is in the area. They're 24/7 operated. We have about 10 operators in the main control center, another 5 in the Lincoln control center all the time, 24/7. California ISO, RC West, within its balancing authority area, the California ISO itself, the balancing area, they run the generation market and they balance energy to load, maintains electric reliability on the grid. They manage the flow of energy. They oversee the transmission planning process, operate the wholesale electric market. It's a big part of our business. Much of the Western U.S., the ISO operates the Western energy imbalance market. So there's two markets running, and then we serve as the reliability coordinator for much of the Western United States. Our regulators are NERC and FERC, WECC. Branden and Mark here are one of our regulators. We have strong partnerships with them, and we really consider that a partnership. They are our regulators, but they help us do a better job at it. So we really have that. And the California ISO is governed by 5 board members who are appointed by the governor of California. The EIM market also has another board of directors. That's a board of directors at large for the Western United States. This is the RC West service territory. We have responsibility for all these BAs. There's 42 BA TOPs in our area. If you notice CAISO in California, you'll see CAISO, but you don't see Southern California Edison, PG&E, or San Diego Electric, right? They actually report to CAISO first, ISO, the balancing side, who reports up to the RC division within California ISO. So that's a little bit of a nuance that you don't see everywhere, but it's here. So you can see we have a very large portion of Western United States. Again, we have two operation centers. Our peak load, which was September 6, 2022, was 130.9 gigawatts. So a sizable amount of energy used. WECC total load at that same period of time, they also set a historical record, which was 167 gigawatts. We have 42 balancing areas. We also have Sinanse, which is the northern part of Mexico. They contract RC West for RC services as well. So the Tijuana area. And we also coordinate with the other RCs in Western Interconnection. So there's 3 other RCs. We go back up to this map. The white area you'll see in the Western US, that's SPP RC, Southwest Power Pool. They operate actually in the Western Interconnection and the Eastern Interconnection. And then we also have British Columbia, the province of British Columbia. They're an RC and a balancing area, and Alberta, and they connect to us. So we manage power flow across those, and we coordinate them with them. And this is an area of really all the RCs and ISOs in the United States and Canada. So you can see there's a large group of them. SPP, of course, is on both sides. ERCOT is sort of an island on themselves. They're only connected by DC ties in themselves. And then you have the Eastern Interconnection, which is MISO, FRCC, TVA, PJM, Ontario, Hydro-Quebec, New York ISO, New England ISO, and others. Saskatchewan and Manitoba are connected to the Eastern Interconnection. There's small ties between the two, but they're really not significant at all. This is just a picture of our control room in Folsom. So you can see the video wall and the operator desks, and we have a replica of this control room in Lincoln as well. And that's it. That's all I have.
Good, thank you. So our next guest speaker is Ahmed Zamzam, doctor, who's from the University of Minnesota. It's not a bad place. I know University of Wisconsin was good. I have my legs in both worlds. So yeah, you went to both. And Ahmed, of course, is coming to chat with us about the National Renewable Energy Lab and some of the unique work they're doing there. Thank you.
Thank you, Mark. Yeah, thanks everyone for coming. So at glance, NREL is a national laboratory that has main campus here in Golden. We have another campus in Boulder, one in Alaska, and an office in DC. We work on everything related to energy. Started as a solar energy only, but now we do anything related to energy and integration of these renewable energy resources in the grid. We divide our objectives into these 3 objective areas from integrated energy pathways, electron to molecules, circular economy, for everything related to renewable energy and how you recycle this back. And my focus is in the power system, which is related to the integrated energy pathways and how to basically increase the integration of renewable energy and do this reliably without affecting the current practices, and how reliable the current systems are, and the impact of that reducing pollution that are coming from conventional generators. So try to use this. Okay, good. So this is a very nice figure that we want to highlight. This is the system sizes of power systems, and this is the percentage of wind and solar of generation in these systems. And you can see for smaller systems, in terms of at this scale, we have reached 100% instantaneous power and 100% annual percent of the energy used in these small systems. And what we hope to do is to get our larger grids also to a level where the instantaneous power is at 100% and the annual percentage of energy is at 50% at least. And as you see here, for larger grids, we are far from there with the current numbers that we have here. So in our center, we focus on how we operate renewable energy sources. So we make them more reliable, and we increase the adoption of these resources in grids to reach these goals, and increase operational efficiency by delivering or using the energy that you have from the renewable energy sources efficiently to serve loads in the system, using tools from control, AI, and optimization. And also contributing to the electrification and changing devices that use other sources of energy to electricity. So one of the recent projects or tools that we are developing is DynaGrid, which stands for Dynamic Microgrid for Large-Scale DR Integration and Electrification. And the goal of this project is to basically develop a framework where we are able to operate distribution networks when we need as dynamic microgrids that connect and disconnect from each other. And the goal of the goal for this is to improve the T&D coordination between systems when you have this capability of connecting, disconnecting microgrids, and utilize the capability of grid forming inverters that are able to isolate microgrids in systems, and integrate efficiently and leverage large-scale DARs within systems, and increase the decentralization of decision-making in systems, which then allows you to reduce risks of any outages or events that you don't want to happen to the customers. And one of the main goals of this is to improve equity and justice. So one of the use cases for this is when you have an event that that you anticipate to happen in the future, how do you plan your system and resources beforehand so that knowing the time of the events happening, you can change the configuration of the system, you can change the connections in the system so that you can reduce the risks of power outages, or you can recover the system faster after an outage using grid forming inverters and microgrids that are able to connect to each other and then connect to the main grid back. One of the scenarios, for example, is this use case that we applied on the data from Hurricane Dolly that happened in 2008, where we have data for the path of the hurricane and how we can adapt our system preemptively to handle this scenario and minimize the power outages both before the event and during the event and after the event, be able to restore the system more accurately. And another use case is for wildfire, which is applied for wildfire prevention using power safety shutoffs, integrating energy justice metrics, and also using these metrics and operational strategies to prepare during wildfire events and analyze during a wildfire event what are the more susceptible lines and how do you plan your systems and do your resources within distribution systems to operate and ride through during this event. And we have done work in collaboration with the University of Wisconsin. Sophia here is going to talk about this work and that we did in collaboration with Sophia and Lena Rowell, incorporating energy justice and vulnerability indices to characterize the vulnerability of people. So if we have a community that, for example, rely on electrically supported medical devices, we will prioritize them not to have power outage over other communities that have other resources, have other that have lower vulnerability, basically. And with this, I finished. Thank you all.
Speaker is from Tri-State G&T, and his name is Curtis Hartenstine. Hartenstine? All right, sorry about that. And thank you.
Thank you. Yeah, no slides. You're gonna have to look at me, sorry. Or your neighbor, whatever you choose. Yeah, I'm Curtis Hartenstine with Tri-State Generation Transmission. Thanks for having me. As mentioned earlier, I am a stand-in, much as the gentleman from NOAA was. I'm coming here to report in lieu of John Hansen, who's my supervisor, who really is an individual that has championed much of Tri-State's work in the wildfire mitigation and risk reduction space. So I'm proud to support the organization. I've been here for about 3 months. Up to this point, I've been working for a larger water utility in the region. And a big function of my work with that utility was wildfire risk reduction for the source water protection of our lakes and reservoirs that we use as a distribution system to serve over 1 million people. I have an undergraduate in forest ecology, a master's in environmental science. So really, I come at you with a watershed science perspective to this work, which is, as far as I've seen, and again, I'm new, a little unique to the industry, but hopefully I can leverage what I understand, complement it with folks like yourself and others in the industry to make the most robust program that we can possibly do. I'm going to talk to you today a little bit about how we're evaluating essentially some satellite data to better understand wildfire risk and a number of other objectives on our system. The objectives that we have for utilization of these satellite data really focus on the line and the wire zone itself. So what's that wire zone? It's what's in the right of way, narrower in the right of way. And then beyond that, what can we do? How can we understand the vegetation components and other features within that area to understand encroachment, how high a tree is growing or some other vegetation is growing directly under a power line that may interact with a power line and cause an issue. We want to understand strike and hazard trees that may be outside the wire zone or in that near area that would fall down and cause a strike and potentially start a fire. We want to understand how we can utilize that data for regulatory compliance. You heard some discussion on FAC 03. This is a regulatory requirement we have for some lines that dictate how close we can allow vegetation to encroach those lines before we're out of compliance. And we don't want, of course, be out of compliance. We want to understand change in forest health over time. Are the conditions that we're seeing now leading us down a path that we can better understand and prepare for and maybe communicate with the landowners that our lines and our right-of-way exist upon? And the other thing that we're trying to do with these kinds of satellite data is better refine and understand the fuels in the wire zone and how that data can be fed into broader wildfire risk assessments. So if we are able to better segment our system into large lines, and a line can be anything from one structure over a couple hundred yards to several hundred structures spanning, tens of miles, tens of miles. How can we understand if we were to have an issue in this particular line, how does that relate to its prospect for generating a wildfire, and how might that fire react from that cause? So this is a really good timing for this particular topic in this particular event, because I was literally in Taos yesterday working with a vendor that we selected to run that satellite over our lines in the Black Lake Taos area, which is for us a very high wildfire risk area. We also had that line flown with LiDAR, drone-based LiDAR as well in recent history. And the objective of my site visit was to evaluate how precise, how close are these varying types of technology accurately capturing some of the vegetation heights and other features that we've selected. And then we were there with the field, with the maintenance crews who normally use laser rangefinders to calculate those heights, to field validate that. And also, I think just as, or maybe even more important, get the perspective from those maintenance personnel on how truthful are these data. Do they make sense to these personnel who are on these lines in all kinds of weather, who may have built those lines, and nobody knows more about that to those maintenance staff. So I want to give them a little credit there for their distinct understanding of that system. So we're really looking to see what fits for us. Is the satellite data going to be sufficient for our needs with those objectives that I mentioned in mind? Do we need to do LiDAR and get maybe a greater degree of precision to that data to achieve those objectives versus what our crews are already doing out there in the field? And really it comes down to cost, you know, as we're making that decision, reliability of those data, and timeliness. The greater the cost, the less likely we're able to fly those lines. If we're able to get our needs met with satellite data at a cheaper cost, then we're able to fly them, or you're able to grab that data, process it, and use it more frequently. So during that 8-hour drive from Taos yesterday, which is beautiful, right? Unmistakable this time of year, especially, although very long, I started thinking about some lessons learned. You know, what do we gather from this site visit? How am I going to talk to you folks about what we learned and better, you know, facilitate a conversation about how these kinds of data can serve the needs that I explained earlier. And the first thing, you know, that came to mind is this is a fantastic tool. These satellite data, these LiDAR data, these are all wonderful tools to have in your toolbox. But I'll say, I know 0 of our maintenance crews that go out with one tool. They have a whole lot of tools. And so I think this is in a similar metaphor, a way that we can look at this. This is a tool in our toolbox. It's not the only tool. It won't completely eliminate the need or the desire for us to have eyes on the lines and boots on the ground, but it's a great tool. It's certainly rapid. It's standardization. We have over 5,000 miles of lines. Right now, it's individual maintenance crews going out making these assessments, doing these patrols. They do a great job, but they have different training. They have different conditions. Maybe one guy does it 1 year, maybe another guy does it another year. So this really allows us to standardize the way in which we look at these lines and how we report on them. It's very valuable for tracking conditions over time, right? We can see that progression of the forest, the progression of the vegetation over time in ways that we wouldn't normally capture with our current patrol system. And again, as I alluded to earlier in some of the comment section, it really provides us another layer of evidence and justification for the kinds of work that I ask my boss to do, that my boss has to report to gentlemen like these guys from WECC and NERC on how we are conducting our operations, how we're meeting our requirements. Helps the attorneys understand that we're doing everything we can in our power to achieve the greatest results. So those satellite data really feed a great deal of those kind of needs that we have and offer us a great deal of versatility in how to execute that. I think as we were on the ground with those field crews and with the satellite vendor that we had selected for this work, it became pretty apparent that the challenge in making actionable decisions using satellite data was not in the data capture themselves nor the processing, but it's how to turn those data into information. How do we develop a dashboard? How do we develop a risk matrix? How do we develop GIS tools? How do we put something actionable in the hands of myself, who can work with those crews, or directly to those crews who've got a lot of other work to do? How do we communicate the results of that data to those crews? And that's where I found it was extremely valuable to have those gentlemen with us, so we could really talk through, well, how are you going to use this? And, great, that's an interesting data point. It's really cool. It doesn't motivate me to do one thing or another. So we found out a lot through that site visit on how to turn those data into information and then action beyond them. Another takeaway I have, and I'll leave with this, was, and maybe this is my watershed kind of science background speaking, but it was the need for collaboration as we develop and utilize these tools. How can we share them with our Forest Service or BLM partners or private landowners to complement work they're doing on their own lands? Can we feather their treatments into ours? Can we cost share? Can we adjust each other's definition of risk and level of importance through that level of coordination and collaboration? And I think that there are many options out there to do that work. And when you have the power of the satellite data or LiDAR data, you know, whatever you have that gives you that best level of accuracy, that really enables those conversations to move a lot farther. So I thank you all for your work. Thank you for your time. Look forward to having any questions a little bit later on.
Thank you, Curtis. I guess now we'll impanel the panel. No, we got one more person. That's right. Now, why is this? You know, I'm a golden gopher. Now we have the Bucky Badgers, a bunch of rodents from the Midwest, vicious gophers, you know. Yeah. But anyway, he'll be chatting. He's from the University of Wisconsin, a student there, and look forward to the research results. Thank you.
Great, thank you. That's not going forward. It's going side to side. Yeah. Interview slideshow. There we go. Great. So yeah, my name is Rhodes. I'm a fifth-year PhD student at the. I don't want slideshow. It'll just advance by itself. Full screen. Thank you. Fifth-year PhD student at the University of Wisconsin-Madison in the Department of Electrical Engineering, Computer Engineering. I'm also in the Energy Analysis and Policy program. My work is on power grid modeling. So everything that I do is around being able to plan public safety power shutoffs and taking into account the different trade-offs that are involved in this problem. I don't do any direct work with wildfire risk, but I use the wildfire risks to be able to plan these problems. And that's why I'm very interested to be here and to hear from all of you guys about how do we actually develop these risk metrics and what do different risk metrics actually mean as a result of how we use them in planning power shutoffs. I prepared several slides here, not directly about my research, but just general problems that I think about as I've been working on this problem. And I think every single one of them has been talked about so far today. So I'm glad that everybody else is sort of on the same page, but maybe I'm going to highlight just a few of these things here. So we all know that power lines are impacted by wildfires. There's direct damage to the equipment. There's an increased risk of flashovers from all the smoke in the air. But also we've talked about how power lines can ignite the fires themselves. I think of these as being two different issues, mostly because of how utilities are able to potentially control how likely their equipment is to ignite the wildfire, but they don't have much control outside of their right-of-way of their equipment on how big that fire might become if an ignition does happen. And that's a big part of like, how are these wildfires going to be spreading is about the land management that's around all this equipment. I want to also clarify that these ignition events are not uncommon. So these, this is also already talked about, but this is happening across the US and it's becoming a lot more common. The impacts of these events are also, can be quite deadly, but not all of them are. Maybe if you take a look at those PG&E numbers, 400 ignition events from 2015 to 2017, that probably correlates with 1 in 100 being one of these mega fires. But that means a lot of these ignition events do not result in these massive damage events. What is interesting to note is how often wildfires are these most damaging events. So this is from analysis from San Diego County, where power lines were found to be the ignition source for about 5% of fires, but about 25% of the area burned was from fires ignited by power grid equipment. So this is, I think, a big reason why we want to talk about the power grid and wildfires is because the largest spreading wildfires that we can see here are being caused by power lines. Another metric I don't have on one of the slides here is about all the fires across California. Looking at the CAL FIRE annual reports, about 10% of all wildfires in California are ignited by power lines, and they represent 70% of the damages by value of all wildfires in California. It's these Same events that kind of make these wildfire ignitions more likely, these really high wind speeds that will cause a conductor slap or cause trees to fall on the lines, also fuel those flames and make them these most deadly, most damaging wildfires. There's a lot of methods to be able to be reducing this ignition. My focus area is on the public safety power shutoffs. These are the most extreme measures to be able to take, but it's because they're the fastest to implement that we want to use them. There's a lot of planning that gets involved in terms of upgrading the infrastructure, better vegetation management, addressing all those changes, but that is investment that will take a lot of time and a lot of money to do. And in these emergency scenarios is when we need to be using public safety power shutoffs. But again, the important part is that they're an extreme measure to take, and we want to mitigate their uses as much as possible and invest in the grid so that we never have to use them again. As an example of this, 2019 shutoff that Pacific Gas Electric conducted. I believe this is the largest public safety power shutoff conducted, and 2.5 million people lost power in this event. Pacific Gas and Electric reported that they found 114 instances of damage on de-energized equipment that may have led to a wildfire. This is a little bit lopsided in the certainty we have about the information here. We know the 2.5 million people who lost power by this event, and 114 events that had damage that could have been ignition, that could have spread into a wildfire, that could have been a really damaging wildfire. So people have already talked about this, but we don't have reliable confirmation that the de-energization was actually as effective as we hope it was. Considering 2.5 million people lost power in this event, these are big impacts that we want to be able to better understand what the impacts of actually conducting these shutoffs are going to be. The last thing I'm going to talk about is about wildfire risk data. I just put up a few different data sources up here for different kinds of risk metrics that could be used to be able to plan public safety power shutoffs. And mostly what I want to say is they're not good enough right now for the kinds of things that we want to do. We need much tighter resolution around where these power lines actually are. We need information that's updated fairly quickly. So this hourly data would be really great to be able to access so that you can mitigate the amount of time that the outages are going to happen, so that you know where and how quickly events are changing, so you might need to conduct these events. On the left side here is two maps put out by the US Geological Survey. They have a large fire probability map and a fire potential index. And it'd be great to really understand what the difference between these are, because there's a lot of different names for some of these metrics. And as a power grid person, I don't know what the difference is sometimes. So I'd like to be educated a little bit about that and want people here in the room to be able to tell us more information about what we should be concerned about when it comes to these ignition events when we're talking about the power grid and whether we need to be turning it off under extreme situations. So that's everything that I have, and I hope we can have some good discussions about this.
Thank you, Don. Now I'll unpanel the panel. As y'all come down here, and I think that these were some really insightful, great presentations. And I'm really excited perhaps about some of the potential questions that you're all going to get. Does anybody have something right out of the box?
Can I just ask a clarifying question about that? Well, to the last speaker, but maybe to others.
Yeah,
a lot of the fire predictions or risk maps are CONUS. They're the contiguous US. And I heard from several of you that you are international in scope. You were in Tijuana and some go up into Canada. How limited are you by just having these US centric like risk maps and information and data sets?
It's impacting, oops, sorry. The fire that's impacting their facilities that could cause issue in the continental United States. Yeah. So there's a lot of coordination. That's why they call us reliability coordinators, right? We coordinate with all our BAs and TOPs that are underneath us, as well as our adjacent RCs and their TOPs and BAs.
Within the industry, there's a lot of information sharing. When you get to government, that's where it kind of shuts down. We gather data at NERC, but we can't share it with the US government because the Canadians, they get to take that up front to that. There's that whole Tea Party thing and all. Anyway, it's a long story. So Quebec, so, any other questions?
So Mark, if I could maybe
Yeah, please,
comment.
Steve.
Currently WECC is only the last couple of years, we've only looked at the US entities simply because this initial request to conduct this wildfire data request came from FERC originally. And so we did not include our Canadian or Mexican entities. Obviously, it's been an extreme year in Alberta and British Columbia this year. We are definitely considering conducting a separate standalone Canadian data request. And that would be for the WECC review only, since they are not under the FERC jurisdiction. So this would be a separate data quest, but we're obviously concerned with the number of fires that are currently burning or have been burning in Alberta and Canada and the impact that they've had. So just a commentary there on the risk, and are we looking at beyond the US? And yes, we are.
Thank you. Any other question? Yes, sir.
Thanks. Joe Casola from NOAA. We've talked a lot about kind of wildfire impacts on both reliability as well as kind of damage to assets. What about for the price of electricity? We haven't really talked about that much today.
Okay, I'll take that one as best I can. It's a loaded subject. But I can use an example, I guess is the best way to explain it. If you look at California and Oregon, there's the California-Oregon interface we call it the COI. And there's 3 500 kV lines that come across that. It's capable of approximately 5,400 megawatts of energy. So a lot of energy can come down that corridor into California. Oftentimes we have fires that threaten that area, right? So you're buying spot electricity on the market, or it's been bid into the market at a price. It's much cheaper than running gas in Southern California, for example. If there's a fire there, and if it's an extreme fire where it's threatening the whole corridor, in other words, we have to protect for what we call open loop, which would be a total separation of California from Oregon. And the power would have to go all the way around Oregon, all the way around through Colorado, Nevada, Utah, into Southern California, which is very trying on the system. We can move some of that energy, we can't move all of it. So what has to happen is we have to compensate for energy in the California, LA Basin, Bay Area. So they'll bring on more expensive gas generation that's been at a higher level, and it directly impact the price to the hundreds of dollars per megawatt. So it can be significant at times.
Exactly. And Tim and Curtis, you can keep me honest here too. Then there's the hardening aspect. And I know they're doing a lot of work in PG&E to kind of go back and refit and retrofit and strengthen, as well as to harden against fires. That also, of course, is costs that get socialized to the consumer over time. So I'm sure and we're going to be seeing a lot more of that as we see this weather changes as a result of climate change, be the heat or the cold, the windstorms, you name it. So, and really the question is, well, what is the weather bookends that I need to design the system for? Because I can't design it for everything, but that's changed now because the weather patterns are changing. What is a reasonable level so I can start investing in that, knowing that I have to recover when I get beyond that? In other words, I can't build it for every hurricane, but I'll build it for certain levels of hurricanes, right? Anyway, I went off on a tangent there. I'm sorry. Is there some more questions? Yes, sir. I'll give you my mic. This is the golden mic.
This is to Noah, and if other people can expand, that'd be great. First time I've heard about smoke-induced induction and flashovers, and then also conduction slap. And I'm wondering, so I understand conduction slap. I know that at least in Wisconsin, I was talking to, We Energy, and they do a thing where they wrap the wire, so there's a conical kind of wrap that supposedly reduces that. Yeah. So are those, first of all, how much how much of it is tree falling on power line? And how much of it is this, conduction slap and those kind of things? Or is that not really clear?
I have no idea what the range is on maps. These are mostly things I've heard about from some other researchers that specifically work in identifying sort of failures, outages that will happen on the grid. Like, well, these are things that cause it, but I personally don't know any information about the ratio of.
There's
falling down. I
probably
don't know if
some
you know.
numbers around because we collect transmission outage data at NERC, and I probably could dig it up. But what it really comes down to, if that line still is energized, which it may not be because the fire's coming, so you might take it out anyway. Then that carbon buildup on the insulators creates a short circuit, and boom, you're on your way, and it's going to trip it out. It'll create an arc, which is not pretty, but you already got a fire anyway. The real. You have duty on the breakers for sure, and you're going to have to go clean those insulators off no matter what. Even if it wasn't energized, there's still going to be soot and crap all over your insulators. Excuse me, that's an engineering term, crap. But then of course there's the damage to the structures themselves, right? The slapping is usually from wind, right? And again, if they know the wind's coming, they're going to take them out unless they've been able to get enough, go through redesign on those to spread them out further, so they won't get close enough to provide a line-to-line fault.
Yeah, I think soot does contribute to most of the fire outages that we have on a transmission system. Like was mentioned earlier, there are requirements for utilities in their vegetation management program to prevent trees from falling on line, whether they're on fire or they get blown over by the wind. So that is greatly reduced, generally speaking, but it can happen. We do have some structure fires where the structures are out of wood. The transmission structures, those burn up, but your higher KV systems are generally steel construction. So we'll get a flash over on one set of conductors with a lot of smoke, and then we'll carry the ionized gases, will carry through the smoke into the next set of conductors if it's a double circuit tower, and take that out as well, or an adjoining tower.
Maybe one
Yeah,
of the
Tim,
comments also about
sorry. The very picture behind me is an extreme example of a corridor with 4 345 kV lines, a couple 230s, double circuit 138. A simple grass fire through this particular corridor here could almost take out every single line simply from smoke, causing strikes of flashover from one conductor to the other conductor to ground. And not uncommon, but as Tim alluded and Mark alluded as well, smoke can contaminate the insulators, and eventually downstream, you can have rain and things happen to where you have tracking down the insulators and outages as well. But smoke is a common cause for high voltage lines being taken out of service, forced out of service.
I'll just say that to me seems like a really prime opportunity to use a lot of the tools that are being developed now. For example, her smoke. I mean, if you have some idea of what the particulate concentration that leads to this, you could add that to your suite of management practices.
Absolutely, along with your impact on your solar resources too. Yeah.
Maybe one other thing I also want to highlight is about the difference in transmission and distribution grid. So I think most of us on the panel here focus on the transmission side. But most of the lines are distribution lines, lower voltage distribution lines, and per mile, faults happen 3 times as often on the distribution system than the transmission system. So there's just, in general, there's more of those lines, but the vegetation is also closer, doesn't need as big of a right of way because it's lower voltage. All this kind of plays into that when you have 100-mile-an-hour winds, the tree is more likely to hit that distribution line. Yeah. And that's where a lot of the more dangerous wildfires are going to end up being ignited from, is on that distribution system.
That's a good point. No, you're absolutely right, because they don't have the same kind of standards because of the voltage and the clearances and all that. It would be a very expensive proposition if you try to do it. But 87% of all outages the consumers are exposed to, at least 87. That was the number I carry around my head is distribution related. Yep.
So Mark, Steve again.
Yes, Steve again.
Yeah, I was listening to Noah's presentation and then thinking about what I had just said 15, 20 minutes earlier about that we only saw 10 incidents where facilities were reported as to causing wildfires, and Noah had several hundred. one of the things that I should recognize here is that we're asking for 100 kV and above. For the most part, and Tim, you can correct me, but most of the facility caused wildfires is generally at the distribution level, the sub 100 kV level. It is our intention that we're seriously considering expanding our request to looking at wildfire facility outages contributing to sub 100 kV as well. So just wanted to make that clarification. There was an obviously extreme difference in the number of events where we reported facilities caused fires and what NOAA had reported.
Because NERC is responsible and WECC responsible for what they call the bulk power system. And it's a kind of a weird distinction, but basically 100 kV, give or take 100 kilovolts and above. We say that's interstate generally, unless you can prove to me otherwise, and they have to follow certain standards. Below that, it's more state jurisdictional. So that's why we kind of focus on the higher voltage stuff. Any other questions? More questions? Yes, way in the corner. Go, Branden. Gonna get some steps in.
This is very general, but I'm wondering, multiple organizations here are, as your daily routine coordinating across many energy companies and transmission companies, your operations and your markets. And I mean, what we're seeing here today is, there's a long-term, this is really a research question, right? There's a lot of unknowns and a lot of common challenges, but also unique challenges for all of your member organizations. I'm wondering culturally, how your organizations, think about your members cooperating. I think Curtis made a point of sort of ending on this idea of a need for cooperation. Are there any examples of other major industry issues that required just a great deal of that really looked more like research, or do you feel like there's mechanisms in your organization to sort of gather members for collaborative, problem solving and forums, or does that come from somewhere else?
I can take a stab at it a little bit from my perspective. So NERC has a set of requirement standards, right? And they're developed, but they were developed by coordination of many BAs, TOPs, RCs in the country to write these rules that we have to operate the system by. Certain parameters we have to maintain, communication channels we have to maintain, communication ability we have to maintain and test, et cetera. So that's one broad example of it. Another example, I think, and maybe Steve or Branden can talk a little bit more about the RBR standards that we are working on with the integrated, based resources going forward, batteries and such.
And I'll even go further back than that. So, the power industry in general, organizations like WECC and NERC were formed in response to major blackouts. The first one of those that really hit the news was the 1965 blackout. And at that time, we started to really understand the impacts of interconnected systems. And so that was about the time that NERC and WECC were started. And at that time, the purpose of our organizations was to bring the different utility members together to establish common standards, to establish common ways of planning and operating the system, because they realized that their neighbors could have direct impact on them and their customers. So, I mean, that still to this day propagates whenever there's a major reliability or security challenge that comes up. Organizations like NERC and WECC, we work directly with the utilities and other industry stakeholders to identify if standards are needed or, what we need to put in place to mitigate these risks. And so, we could probably come up with several different examples of industry getting together, collaborating, trying to understand best ways to solve problems.
Sure, go ahead, Curtis.
And in another way that we kind of collaborate very directly is in Tri-State's examples where we serve those local cooperatives that we've talked about today. Well, those cooperatives each have a seat on our board, and that number, I'm going to get it wrong, it's between 15 and 20 that come and sit on our board of directors and talk to Dwayne and tell him what they think and tell him how things could or should be done. And that's a very direct feedback because we really take it to heart that we work for those co-ops and their voices ring very loudly with our senior management. And if there's enough push behind those board members, I mean, that will move our organization to respond in a number of ways.
Tim has same examples too with your stakeholders, right?
Yeah, there is. And I was thinking more of trying to think of a technical
Right.
example, and I did come up with one. So we have a PMU phaser synchronous data devices that we can put on the grid, and they were developed by Schweitzer Laboratories in Pullman. And what we use for those is to detect oscillations on the system. So to govern the use of those, the utilities had to bring up money to install those in the system. Wasn't trivial. And we have an SMWG working group, synchronous measurement working group, which is an industry nationwide group of SMEs that work on these phaser measurement units and the data that collects and the information we use for it and how we can use it to make the system more reliable and actually change the way we operate the system in some ways as well. So try to progress into the future. So there is a pretty rich environment.
And yeah, we're right now inverter-based resources, behavior of them, bringing industry together to crack that tough nut. Another one is energy versus capacity. Another group of folks have come together. So we bring folks together all the time, and including researchers if they're willing and able, because our meetings are open to everybody. Sometimes we're closed, but generally speaking, most of our groups are open, right? I mean, and you can participate and be a member or not. Doesn't make any difference because everybody has equal voice. There's not a lot of voting that goes on in the working groups and subcommittees. So it is a collaborative model that it was established, as to Branden's point, after the 1965 blackout. Also, EPRI, the Electric Power Research Institute, does collaborative research, again, to tackle tough problems. And we many times interface with them too. I'm sure, as my colleagues here do, of course, NREL, I'm sure you'd bring together subject matter experts or SMEs to tackle tough problems, right?
Yeah. So one of the areas recently is the integration of these grid forming inverters, and these are devices that are able to operate grid in AC mode in isolation of the main grid. And these are currently they are not widely used, and every company is making their own devices. If you test them, you see different responses, and there are efforts to bring in everyone to the utilities and manufacturers and vendors and researchers and everyone to come up with a standard to operate these devices. So the industry has seen, yes, a lot of examples of collaborative.
I think you've been working with Ryan Quinton on our white paper on that. Yeah, good stuff. So we probably over answered your question, but it's a good question. It's one that gets us all excited. We love working together. You know,
one part to that. I think those are all good evidences of past coordination. What do you guys actually see as the future of any work towards dealing with wildfire risk within these organizations?
I was actually going to bring that up because there's an interesting nuance when it comes to wildfire mitigation, and that is some of the states like to control the issuance of wildfire mitigation strategies and kind of dictate some of the rules around that. And so although, organizations like WECC and NERC, we can bring entities together when it comes to wildfires and be a forum for information sharing and education. It is one area that we've kind of stayed out of and allowed the states to set a lot of the rules and the standards for the utilities within their state. So
exactly. In fact, the law that set us up says that we can't get into safety explicitly, but we're not feckless. We do bring people together. That's for sure. We have maybe one more question, or else I'm going to ask Branden to ask. Yes.
Unless someone else has one, I always have questions. So amid this idea of dynamic microgrids, and it sounds like that is something that you're trying to get coordinated at a industry level. What's the cost of retrofitting that, and how do you see that? We're also going to solar and wind. It seems like having a dynamic I completely agree. You need to have a full transmission infrastructure, but having these microgrids, dynamic ones, how would that help mitigate some of the public, the public safety power shutoffs and that kind of thing?
Yeah, that's an excellent question. So these things, most of the benefits you see when you do operational planning over 1 day in advance or something like that. And you can see that if you have a battery that you can charge beforehand, and then you can isolate the system and operate it during the hours of high wind, you can operate the system in isolation and then bring it back to the system. And during this time, you have shut down some lines that prevented potential wildfires. So you see this when you operate the system in, like when you do operational planning.
And what Ahmad's talking about is even bigger when you think about it, because it used to be when those lines go out, the distribution goes out. But to his point, when those lines go out, you still have some energy available to the consumer. So for a period of time, at least, right?
Yeah.
And so that improves reliability. It gets to the distribution problem. So excited about it. Just please make sure it's built cyber robust. That's all I ask.
Yeah.
We are out of time, are we? Why don't you join me in thanking the panelists then?